Welcome to VAK's lecture. In this video, we will see a new algorithm, that is how to insert a new element into an array. So first we understand it with an example. Later we will write the algorithm. Let us suppose there is a memory strip and I have made some partitions on it, and also I named it as LM. For these partitions, we will give index values like 1, 2, 3 and 4. Also, we write some elements like 20, 10, 50 and 17. You can see that the total number of elements is 4. So, 4 is the size n of given array LM. Already we have discussed very clearly about these arrays in our previous videos. Links are in description box. If you want, once you check it out. Okay. Now, let us talk about which element we have to insert into given array LM. Let us denote it as item. So the element which we have to insert, that is to be stored in item variable. So user will read it. Suppose 40 is the value of item. Then where we have to insert it? The best and easiest way to insert an element is at the end of the array. In our array, the last position is 4. So after this 4, in fifth position, we have to insert. Let us consider that position is k. So k is equals to 5. That means at fifth position 40 will be inserted. Okay. For this insertion, up to at what position we have to move? Up to last position we have to move, right? Already we have the size or the number of elements is n. But after inserting, how many elements we will get? N plus 1, right? So the size of the array LA will be n plus 1. And one more thing, not only we have a chance to insert an element at the end of the array, we may insert at the second position or at the third position or at the beginning of the array, or at any position we can insert. So we have to find out the condition basing on all these cases. So what's the condition? The position at which we have to insert, that must be less than or equals to size of the array. So how to write the condition? Where k less than or equals to n plus 1, right? So previously at what position we have to insert 40? At fifth position. So in a generalized way, how to write? LA of k is equals to item. Here k is the position and item will be the value which is going to be inserted. So this is the generalized equation. So when a new element is inserted, this n value will be incremented by 1. That means n is equals to 4 plus 1 is equals to 5. Basing on this, we can write the generalized equation as n is equals to n plus 1. So exactly you should remember that whenever a new element is added, your array size will be reset and its value incremented by 1. This is the example for inserting an element at the end of the array. Now we will see the remaining. Now I have taken k is equals to 3. So at third position, I have to insert element 14. So I removed 5 and placed 3. So LA of 3 is equals to 14. So what we have to do? We have to remove 50 from third position and we have to place 14. But what is our list? In our array, 50 should be there, but we have removed here. This is not correct. Previously, what we have done, whenever you insert the element, the array size n should be incremented by 1. So here also we should increment the value of n, which is 4 by 1. So n is equals to 4 plus 1. Then n is equals to 5. Now the size of array LA will be 5. Now to get the empty space at the third position, what we have to do? we have to move 70, which is in 4th position, into 5th position. Means LA of 5 is equals to 17. That means LA of 4 is stored into LA of 5, right? Basing on this, we can form generalized equation. How to form? See here. What is the 4? That is n. That means the size of the array. But now, what is the array size? 5, right? Which is n plus 1. So, how to write the equation? LA of n plus 1 is equals to LA of n. So, what we are doing here? Repeatedly, we are using this equation until we get the empty space at the required inserted position. Ultimately, the n value will be changed. But n value should not be changed. Why? Because n is the number of elements or the size or the length of the array. So, because of this reason, we are using another counter variable j to store n value. So, simultaneously, we will write the algorithm also. In step 1, start the algorithm. In step 2, we will set n to j. So, our j value will be 4. And in step 3, I am not writing for some while. So, come to step 4. In step 4, already we have the equation LA of n plus 1 is equals to LA of n. Here, how to write the j in this equation? How to write LA of j plus 1 is equals to LA of j. Here we have to use j in place of n. Why? Because j is equals to n. This is the generalized equation. For what purpose? To move the element from left to right. Then we will get the space. Okay. In this example, 70 is moved to 5th position. Still we have to move 50 to 4th position basing on the same equation. Now 50 is in LA of 4. That means LA of 4 is equals to LA of 3. If you observe these two equations, in first one 4 is there and in second one 4 is decremented by 1. Already 4 is in j. So in second case j value is decreased by 1. So whenever this equation is continuously running, then the j value will also be decreased continuously. So in step 5, what we have to write here? J is equals to j minus 1. Okay. Now, up to at what limit these two equations will be executed repeatedly? If you observe here, the last position is stored in j and j value is decremented by 1 up to reach k value, which is our inserted position. So obviously the k value will be less than or equals to j. So until this condition satisfies, the 4 and 5 steps will be executed continuously. If this condition fails, then in step 6 the insertion process will be done. But how? See here. Now the third position is empty. At this place we have to insert our element 40. Already 40 is in variable item. Also, the third position, which is our inserted position, is in variable k. So in step 6, how to write the equation? LA of k is equals to item. So item will be stored in kth position. Now, and also always our array size is n, but starting we changed this into n plus 1. Why? For the insertion process, right? So now our process is completed. So what we have to reset here? We have to reset n plus 1 to n. How to do? In step 7, we have to reset n is equals to n plus 1. Then stop the algorithm in step 8. So this is the algorithm for inserting an element into an array, and you can implement this algorithm by using any programming language. So if you got to learn anything from this video, please like the video, share to your friends and subscribe my channel. Also press the bell icon for more new updates. Thank you.